Hello mathematicians, we're now going to take a look at simple and compound interest. Now simple interest, which you first came across in Year 7, is earned only on the principal which has been invested. And as we'll see, it's an AP and it's also a linear function. And it's given by the formula I equals P times R times N, where I is the interest earned on a principal P invested at R%. Which we would need to write as a decimal, and it's for n periods. And of course you'll remember that we need the interest rate per period to be matching the length of the period. Now we talk about it as an AP because if we wrote down the value of the account per period, then the first term would be the principal, and each particular term after that has an amount added to it, so that's our common difference, which is the principal multiplied by the interest rate per period. And because the interest is always calculated on the principal, then that means that this difference will always be P times R. It doesn't change. As a result, the balance of the account can be found as the sum of an AP, with the first term P and the common difference PR. So the graph of balance against period looks like this. So we have our initial amount invested, and every period the graph goes up by PR. So in other words, over n periods the graph will go up by PRN. And clearly that is a linear function. Now we'll just have a quick look at GeoGebra. Now you'll notice that this graph is a variation of the one we looked at a moment ago. So this only has interest on the vertical axis against the number of periods. So the interest starts off at 0, and if we have, in this case here, our principal of 3,000 and our interest rate of 9% per period, 9% of 3,000 is 270. So as we go across every one period, we're going to go up by 270. So the slope of our line is the interest rate. So if I change the principal, then of course my slope goes down because the amount of interest earned decreases. And if I drop the interest rate, then my slope goes down for exactly the same reason. Now if we continue on to look at compound interest, in compound interest, again, as you would know from junior school, compound interest occurs when we earn interest on previous interest. So the account balance goes up more quickly. And what we end up with is both a GP and an exponential function. The equation for compound interest is this one here. But notice in this one that the A is the account balance. So the account balance equals the principal multiplied by 1 plus R to the N. And again, P is the principal, R is the interest rate, which we write as a decimal. So if you thought about the terms in this, if we wrote down the expression for A after each term, we would get that our sequence begins with A equaling P, and our common ratio is 1 plus R. So we're always multiplying the previous value of A by 1 plus R. So that after n years, or n periods, it's P times 1 plus R to the N. So as a graph, that means that the graph will go up steadily if we've got compound interest. We also need to be aware of the fact that if we have depreciation, then that's just like getting negative interest. Something is losing value. So the formula is exactly the same, except we've got minus the interest rate raised to the n power. So the graph of compound interest goes up exponentially. If it was actually a graph of depreciation, it would go down exponentially. So again, let's have a look at the GeoGebra. So on this particular graph, it's a graph of the account balance against number of periods. So if we put $3,000 in and we're not getting any interest, then of course we'll continue to have $3,000 there. I'll just shift that down to $2,000 as the principal, and let's bump up the interest rate. So as the interest rate goes up, our line starts to become more and more significantly curved, as you can see, because we're getting interest on our interest. Now if I make it a negative interest rate, then that's depreciation. So you can see my curve going down. Okay, so let's look at some typical questions. Now you won't get many questions on compound interest or simple interest, but we need to have our head around them anyhow. So in this first one here, a company has bought several cars for this total. There's a depreciation of 15% per annum, and we want the net worth of the fleet of cars 5 years from now. So in that case, it's our compound interest formula. I'm going to use future value and present value, since that's the way that we write A and P in the financial world, if you like. It's the minus because it's depreciation, so then we simply plug numbers into the right spot. So a common ratio of 0.15, we raise to the 5th year, this was our principal, and we get, not unexpectedly, that the cars are only worth 101,000, so clearly then the loss is the difference between initial and final value. Too easy, I don't think you'll get one like that. Next one, also not bad, and therefore I don't think you'll get one like it. Howard's arguing with Juno over who has the better investment. So each person invests $20,000 for 1 year. Howard's invested at 6.75% per annum simple interest, while Juno is 6.6% per annum compound interest. Now, in the first one, if the investments are compounded annually, who has the better investment? Well, the better investment in this case is Howard's, because the simple interest formula gives you $1,350 as the interest earned, so the value of the account is what was there, $20,000 plus the interest. For Juno, even though it says it's compound interest, because the compounding period is 1 year, over that year, compound interest and simple interest, for the first time, are exactly the same thing. So we just multiply by 1 plus 0.066, which gives us this. Now, so I could have used my compound interest formula just with n equals 1, and I would have got this very same answer. However, if we compound monthly, then we're earning interest on interest. So now the formula starts to kick in. So R has to be matched to the compounding period, so it's 0.066 divided by 12 because we're compounding monthly. There are 12 compounding periods, so when we evaluate this, we get this number here, which is a slightly better return than if we put it in with simple interest. So have a go now at 7b. Theoretically, these should be easy, but we know what this textbook can do. But before you start, what are the ideas that you need to bear in mind? What's the point of doing this homework? What are we trying to practice?